All right, Secondary Math 1 class, we are talking about slope some more. Okay, so we are going to be working on identifying slope when given a few scenarios, okay? So on 1 and 2, it's giving us graphs to look at, okay? So it's asking us to find the slope of each line given these graphs. Okay, well, if we zoom into number 1, these are kind of like the questions on your assignments online, okay? We don't see any points on this line, so we're gonna have to find points ourselves. Okay, so how we find a point is we are going to find where it perfectly lines up in a corner of a square. So I see it perfectly lines up in a corner right there. Okay, and then I'm gonna follow this line until it perfectly lines up in another corner right there. Okay, so I have my 2 points now. Now I can do my rise over run. Okay, whenever we're talking about slope, we're talking about rise over run. Okay, so we always want to rise first. So let's start at our lowest point on our graph. That is this guy right here. Okay, and I'm going to rise until I get to the same line that my second point is on. So 1, 2, and 3. So I had to rise 3. Okay, and now I need to run. So from this point where I'm standing, I'm going to run 1, 2, 3, 4. Okay, now a couple things we need to look at before we decide that this is our final slope. Okay, so look at our line. It is going up and to the right. So is our slope going to be positive or negative if it's going up? It is going to be positive. In fact, let's make that note on our paper. Up to the right equals a positive slope. Okay. Okay, so we already know it's going to be positive, so we don't need to add a negative sign to it. The second thing we need to decide is, can we reduce? Is there a number that we can divide 3 and 4 by to make it smaller? Nope, there is not. So we know our final answer, or our final slope, is just 3 over 4. Okay, let's look at number 2. So again, we're not given any points on this graph, so let's find where they perfectly line up in a corner. Okay, right there, and right there. Okay, so now we can do our rise over run. Okay, so I'm going to start from my bottom point. That's right here, and I'm going to rise 1, 2, 3, 4, 5. So 5 is going to go on top. Okay, from where I'm standing on my graph, I need to run. I'm going to run 1, 2 until I get to that next point. Okay, so now we need to ask ourselves our 2 questions. If my line is now going down to the right, is my slope going to be positive or negative? It's going to be negative. Okay, so this is actually going to turn into a negative 5 over 2. So let's make that note on our paper. Down to the right equals a negative slope. Okay, so we know that our final answer is 5 over 2 because we cannot reduce 5 over 2 anymore. There's no number that we can divide 2 and 5 by to make it smaller. Okay, let's look at 3 and 4. So on 1 and 2, we were given graphs to find the slope. On 3 and 4, we're given coordinate points. Okay, so in order to find the slope using coordinate points, we need to use our slope formula, which is y2 minus y1 on top, x2 minus x1 on bottom. Okay, so that is our slope formula. In fact, let's label that. Slope formula. Okay, so now what I want us to do is label our coordinate points. So this is my first coordinate point, 3, negative 4. Okay, coordinate points are always written as x, y, x, y. Well, if this is my first one, then this is going to be x1 and y1. And if this is my second one, this is going to be x2 and y2. Okay, awesome. Now that we've labeled them, we can go ahead and rewrite our formula But instead of writing y2, y1, x2, and x1, just put some blank spaces. So y2 minus y1 over x2 minus x1. Okay, so now we can go ahead and fill in these spaces based on what we've labeled. Okay, so let's look at our y's first. So I have y2 right here comes first, so y2 is 5 minus y1, which is a negative 4. Okay, now on bottom we have x2, which is 9, minus our x1, which is 3. Okay, so let's solve for the top one first. So I have 5 minus a negative. What happens to this double negative? It becomes a plus or a positive. Okay, so what is 5 plus 4 on top? It's going to give us a 9. Okay, so now let's solve for the bottom. I have 9 minus 3 on bottom. 9 minus 3 is going to give me 6. Okay, well, our last thing we need to do is see if it can reduce. Okay, is there a number that we can divide both 9 and 6 by to make them smaller? There is. Okay, we can divide these both by 3 to make this fraction even smaller. 9 divided by 3 is going to give me 3. 6 divided by 3 is going to give me 2. And that is our final slope. We had to reduce it. Okay, so let's look at number 4. So we still need to label our x's and y's. So this is going to be our x1, y1. Okay, and then our x2, y2. Perfect. Okay, now that those are labeled, let's fill in our slope formula. So y2 minus y1 over x2 minus x1. Okay, and we're going to figure out what that is. Okay, so we have y2, which is 9, minus y1, which is negative 3. And on bottom, we have x2, which is negative 19, minus x1, which is 14. Okay, so let's solve for the top. 9 minus a negative. What happens to this double negative? Turns into a positive. So what is 9 plus 13? It's going to give me 12. Okay, now on bottom I have negative 19 minus 14 more. So we're getting more negative here. Negative 19 minus 14 more. That is going to give me negative 33. Okay, now there's no number that actually there is. Oh, we can reduce this. I was wrong. Okay, so we can reduce 12 over negative 33 because again, we can divide both of these guys by 3. So what is 12 divided by 3? It's going to give me a 4 on top. And what is negative 33 divided by 3? Negative 11 on bottom. Okay, now there's no number that we can divide both of them by. So that is as reduced as it'll be. Okay, awesome. So we have currently found the slope when given graphs and when given coordinate points. Okay, for numbers 5 and 6, we are identifying the slope when given a linear equation. Okay, well, both of these linear equations are in slope-intercept form. Okay, which is super important. So let's actually write this down here. Okay, so slope-intercept form is always written as y equals m times x plus b. Okay, and now we need to label what those letters actually mean. So our m, the number in front of the x, is always our slope. Okay, the b, the number on the end, is always our y-intercept. Okay, the y and the x will always stay a y and an x. The m and the b are the only things that get replaced. Okay, so we're looking for our slope. If the slope is always the number right in front of the x, let's look at number 5. Okay, what number or fraction is right in front of my x? Find the x, what's right in front of it? It's going to be negative 4/3. Okay, so our slope is negative 4/3, 4/3. Pretty easy peasy. Find the x, what's right in front of it? Okay, but let's look at number 6. Where is our x in number 6? Okay, we don't have one. Okay, so if we were to rewrite this, this would actually be written as 0 times x, because 0 times anything is 0, and then plus 2. Those are the same equations. Okay, so now what is the number in front of my x? It's going to be 0. Okay, because we didn't have an x, we know it was multiplied by 0 to make it disappear. Therefore, our slope is 0. All right. Okay, now we're going to still use this slope-intercept form, because 7 through 10, we are asked to rewrite these equations, which are in standard form, meaning the x and the y's are on the same side. xy, 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 and xy. Okay, we need to rewrite them in slope-intercept form so that the y is the only thing on that side. Okay, so let's look at number 7. So if I need to get the y to be the only thing on this side, first thing, we ignore the 8. He's already over on the other side. We're good. We don't need to worry about him. So there's a couple of things we need to move that are on the same side. Let's move the farthest one away from y first. Okay, if this is a positive x, what is the opposite of a positive x? How are we going to move that? We're going to move it by negative x. Okay, the opposite of a positive x is a negative x. Okay, and that's going to move him over here. Okay, so now we're going to rewrite it. We still have negative y equals, and when we rewrite it, we always want the term with the x to come first, right? So my term with the x is negative x, and there was a positive 8 that was already over there. Okay, so there's still one thing on the same side as my y. It's this negative sign. Okay, so what this is really saying is this is saying negative 1 times y. Okay, and what is the opposite of times by negative 1? We're going to divide by negative 1. Okay, and everything over here is divided by negative 1. Okay, so we get y is all by itself. A negative divided by a negative is going to be a positive, and x over 1 is just x. Okay, positive 8 divided by negative 1 is negative 8. Okay, another way to think of this, whenever you see a negative sign in front of the y that needs to move, you can think it just has to change these signs over here. Okay, because look at it. We have a negative x that turned into a positive x. We have a positive 8 that turned into a negative 8. Okay, so whenever you see this negative, just think change the signs. And there we go. Our equation is now in slope-intercept form. Y equals something x minus 8. Okay, let's do number 8. Okay, so we're going to ignore this negative 8. He's already over on that one side, so we don't need to worry about him. So what do I need to move that's farthest away? Okay, so this 2x is an entire piece. So what is the opposite of positive 2x? Negative 2x. We're going to move that whole piece over there. Okay, so I get positive y. Yay, it's already by itself, so that was the only thing we had to move. When I rewrite it, I want the one with the x to come first. So y equals negative 2x and minus 8 that was already over there. And guess what? That's it. So we changed it from standard form, where the x's and y's were on the same side, to slope-intercept, where our y is by itself. Okay, let's look at number 9. Okay, so let's ignore -8. Okay, what is farthest away? It's this piece. What is the opposite of positive 3x? It's going to be a negative 3x. Okay, so we're going to move them over there. So we have negative y still left over, equals, write your one with the x first, negative 3x minus 8. Okay, and what was that trick I just taught you? Whenever you see this negative, okay, an easy trick is just to think, change those signs. Okay, so now we got rid of it. It's just going to change the signs on the other side, from a negative 3x to a positive 3x, and from a negative 8 to a positive 8. And there is our equation in slope-intercept form. Okay, let's look at number 10. Okay, ignore the 8, he's already over there. What's farthest away from my y? 5x. What is the opposite of positive 5x? Negative 5x. Okay, so now we have just the y, positive y. Write your one with the x first, so negative 5x and positive 8 that was already over there. Okay, but we're not done. Look back up at our directions. Notice it says, then find the slope once we've rewritten it. Okay, so our equations are now in slope-intercept form, which, remember, our slope is always the number right in front of the x. So if we're asked to find the slope, let's look at number 7. Okay, just look at our rewritten equation. What is the number that's right in front of the x? That's going to be our slope. That's going to be 1. So our slope is 1. Remember, 1 is that invisible number in front of the x. Okay, let's look at number 8. Look at our rewritten equation. What is my number right in front of the x? Negative 2. So our slope is negative 2. Okay, let's look at number 9. What is the number right in front of the x? 3. So our slope is 3. And finally, let's look at number 10. What is our number right in front of the x? Negative 5. Okay, so not only did we rewrite them to put them in slope-intercept form, we actually found the slopes once we were able to rewrite them.